welcome everybody. I hope you're joining us today to learn something about STEM education. You feel about STEM education, science, technology, engineering, and math. So I developed some learning modules. They are, one of them is called wildlife corridors. And it starts with the premise: when we build highways, we usually disturb some wildlife's life, right? There are animals traveling, and then you build a highway, and what happens usually when you build a highway and animals travel? What do you think happens?
The animals get hit.
The animals get hit, the cars get hit, right?
Yes.
So you have damage to cars, you have, roadkill. I mean, you might like it for barbecue, but this is usually a problem. So this is a module that is developed for third graders, but it also can be used in middle school and high school, and it simulates how animals travel. But before we do that, we've got to learn a little bit about how animals travel. So it's an integrated science and math lesson, and so it uses this little bit of recipe called STEM recipe. So it starts with an engineering problem: build tunnels and fences so animals can actually travel safely. And then it uses science in it, and it uses math, like you have a budget, you have you need to test your data. You can also say, you made it a fancy recipe, so it's like incorporating English language art as well as arts like in creativity and craft. All right, let's get started with an activity. So this is what a moose looks like when you cross the highway. It's actually funny, the moose will always survive, the car will not. So it's actually mooses, since they're so big. You see here different technologies that are helping animals. So you have a little bridge over the road. You have even the road being like very high so the animals can travel. You see here little fences, and you see like tunnels, they're called culverts. And so we are exploring actually tunnels and culverts in this activity. So it's an engineering activity. So does anybody know the difference between criteria and constraints? They're being used in engineering activities. Criteria. Like, for example, if I design an airplane, and the criteria would be 300 people go in, 3,000 miles later they come safely down. That would be a criteria. If your airplane doesn't do that, it's not a good airplane. Constraints is like, well, yeah, but when you develop the airplane, you don't have unlimited budget, unlimited money, unlimited people time, unlimited material. So all of these are constraints. So in our case, we'll have 4 animals that are crossing our highway. You see here the little highway model, the black street and the traveling paths of the animals. So 2/3 of one animal have to survive, and 1/3 of the 3 others have to survive in order to be successful. You cannot use more than 5 tunnels. It's just not safe enough for a stretch of highway to have too many tunnels underneath it, because otherwise it might collapse. And you have a limited budget. So, to see a little bit how animals travel, we have these little chips here. They're representing our different animals. So if you want to start the chip, here we go, and just start anywhere on the top and let the chip fall through. Okay, that animal made it across. Let's do another one. Made it across. Made it across. Right now, there are little tunnels built into that already. You can see them. So they make it because the street is pretty much wide open. In order first to see if you can pick up the chips out of the pocket down there, that would be great. So we need to first know a bit about population, how the animals actually travel. So if you step over here for a moment, you see these 4 maps of population traveling. So if you could put the blue chips on the blue, the green on the green, the yellow on the yellow, and the red on the red. Just randomly put them on there. You see on the top the names of the animals. So the blue one is the bobcat, the green is the mule deer, then we have a mountain lion, and the kit fox. Now we put these maps on top of each other. while we put them on top of each other, I want you to look and look how these animals traveling intersect. Who is traveling with whom? The bobcats travel with the kid fox, yeah, blue and red. The mule deer with the mountain lions. Why do you think the mule deer and the mountain lions are closer to each other? Why do they travel together? What do you think? So mountain lions, they eat mule deer. So the mule deer probably were there, and then the mountain lions, they travel with the mule deer because it's a snack, right? So this is predator and prey. The one is the predator and the other one is the prey. So the next part, and I'm doing a 4-hour instructional session, right, in 15 minutes. So we're not doing the entire activity. The next thing what we have like third graders do or is a bit of a math problem. So we place them just on this map, so you see it here now as well. Now we sort them and say, like, on mile 1, if you push them all down to the level, on mile 1, how many of these animals are actually traveling? So if you look at, this is mile 8, how many animals, how many green ones are traveling there?
9.
You have 9, and this is mile level 6, 7, and 8. So how many on 8? You have 3, right?
Okay.
And so kids in this age group, like third graders, they don't necessarily know how to do graphs. So this would be a graphing element where they would actually fill out the graph and show where the animals are. Why is it again important? Because we're building fences and tunnels, so we need to know where actually are the animals traveling in order to know where would it actually be better to put a tunnel, where would it be better to put a fence to kind of guide the majority of the animals, right? Mm-hmm. So then they make another bar graph, this time showing it more the distribution. So this is again transforming this, the top image what we have here, into another graph. So this is where math is integrated in that lesson. And then we're looking at culverts. So I want you to develop now your own culverts. So I have your black paper. Each one of you can get a black paper. Here we go. And you see several different designs here, right? You could make it a long one and make it wider. You can make a long one and you can make it really thin. You can make a short one by just folding the paper in half and rolling it up. Either big or thin. So if you can coordinate that not everyone has the same design. So maybe you make the long one wide, you make the top one, maybe you make a shorter one, yep, and you make maybe a really thin one, maybe a long one. So culverts is interesting because animals, when they see tunnels, like when you are prey and you're trying to escape your mountain lion and your mule deer, you want to see that it's big enough to go through, and at the end you're not being attacked, right? I wouldn't go in a dark tunnel when I'm thinking at the end there's a mountain lion just pouncing on me. So the tunnel needs to be big enough for a mule deer. Now small animals don't like too big of a thing because they're just too visible in there. So they want smaller ones. So we need to consider making bigger and smaller tunnels based on which animal. So now you have your designs. I'll stand here and you each can look at this sheet. I hope your eyesight is good. So if you look through, tell me how many of these concentric circles you see. What's the last circle you see when you look through in your design?
I see all of them.
You see all of them?
Yeah.
Okay.
All of them.
All of them?
All of them.
All right. Let's get closer.
Okay. 8 inches.
8 inches?
1 inch.
1 inch.
All of them.
All of them. So the wider one gives you all. The shorter one gives you a bit more range because you still have a little bit of a distance, and the long one, small one, gives you less fuel, right? You saw just the 1 inch. So what does that mean? What would the culvert have to look like for an animal to see a lot? Would it be wider or would it be more narrow? What do you think? wider, right? And so now I want you to think for a second. This is third grade, at least now. So there are middle and high school adaptations for that. But in third grade, they just learn about fractions. So they don't know much about fractions. So when there's 2/3 and 1/3 of the animal population, they gotta learn how to break what is actually 2/3 of 9, what is 1/3 of 12, in order to know how many have to survive. So there's another math component in there, all right? So now, I would like you to think a little bit. We don't have that much time, I think, but we could, where would you, if you look at the distribution of your animals on this side, right? Where are they traveling? Where are most of the animals traveling? If you look at mile 1 to 8, so mile 1 to 8, where are they traveling? Where are the blue ones traveling mostly?
Mile 6.
1 to 6, right? They have a wide territory. Who else is traveling a little bit in their territory?
The kit fox.
The kit fox, right? And they are actually, bobcat and kit fox, they are also prey and predator relationship.
Okay.
And then the mountain lion and the mule deer we had before, they are tending to be more on the right side. So, this is our simulation. You want these animals to survive. Where would you put fences in? And where would you close off tunnels? So in order to close off a tunnel, we have these little blocks here where you can actually close off a tunnel and say this is not possible anymore, right? We need only 5 tunnels, right now there are 9. So think about where would you put fences. We start the animals here on the top, right where their population passes. So the blue ones we start over here and let them run through, the yellow ones we run over here, and you want 2/3 and 1/3 to survive. Where would you put fences in? Where would you put tunnels?
You should put it in between their population.
Okay. Show me. Yeah. So a fence, you would just, that was a little bit too short. A fence, you would just pretty much just wrap something around it.
Yeah.
Like this is how you would construct a fence. And now an animal that comes to this spot would not go through here, it would get passed by, right?
Yeah.
So where would you put fences?
Like here, since the bobcat would probably go to the 6 miles an hour, just go back down to.
Okay. So where would you put another one? You would put another one here?
Yeah, so like after the 6 miles.
Like this way?
Yeah.
Okay.
Yeah.
How about any other ideas? Which tunnels would you close off? So we have tunnels right down there. They're right now open, meaning we need to close them because we can only use 5.
Maybe tunnel 4.
Tunnel 4, okay. Let's close tunnel 4 because there are not many traveling in the middle, right? Okay. Anything else? Anything else you want to add? So when kids are doing this activity, they have like 15, 20, 30 minutes to think about that, draw it out. So let's bring a couple animals over here and see what actually happens. So let's bring 1 blue, 1 green, 1 yellow, and 1 red chip. You can again run the population. Now blue needs to start between A and, what's the last number over the last letter over there? A to F. So you can start it between A to F. Okay, that didn't make it. It might be just part of how it's falling, but you know, the highway blocked it. Now you could talk about roadkill and stuff, but you know, that didn't make it. That would be an example. Okay, let's run the next one. It fall actually through. So maybe we need our fence design needs to be a little bit tighter. But that one didn't make it either. All right, let's look at the green one. Yep, the green one made it, and it safely crossed the road. Okay.
Red.
The red one? Oh, well, it's just on the fence, right? It's just eating right now. So you can give it a little tap and have it run, have it continue running, right? Man, that's hungry. All right, it made it. So the idea is we're running all of these through, and then kids actually calculate, you know, where are we in this whole thing? How is our design? How well is it? And then they do a reflection at the end. So that's pretty much the activity. It takes about 4 hours total, and kids learn, again, population, wildlife, migration issues, and design a solution to help these animals survive. All right, any questions? Anything that you don't know yet or want to know more?
Would it be bridges or mostly tunnels?
In this model, it's pretty much tunnels and fences. I mean, you could think about doing something else, like building a bridge and seeing how that would work. You would need probably a different simulation. But it's, it's a cool idea. What would actually bridges do? When you could, some of the textbooks that these kids have in science, they talk a little bit about which numbers are better. Bridges have a benefit because it's like the bridges over the road have a benefit because they're open air, right? And the bridges where the cars go higher, they're just a lot of times way too expensive to build. So this, I have a question for you now.
Okay.
So where in this activity is engineering? Right? We learned science, we learned fractions or math and science, that's maybe a little bit more clearer. But where's the engineering in that activity? What do you think?
Deciding where you should put the tunnels.
Yeah, where you put the tunnels, where you put the fences.
tunnels.
How to build the tunnels size-wise, right?
And material-wise.
And material-wise, you can talk about that as well. I mean, what might be better material for tunnels? Yeah? So this would be environmental engineering, it could be civil engineering who do that. There's actually people who do that in Missouri for a living. All they do is building culverts and fences to help wildlife cross. So this is actually a really interesting career path, matching kind of biology and engineering. All right.
Cool.
Thank you very much.